Welcome to Vector Directions with Ma'am T. In grade 10, you learned that a vector is a physical quantity that has magnitude, unit, and direction. And you also learned that you can represent a vector by drawing an arrow, whereby the tail of the arrow gives the origin of the starting point of the vector, and the arrowhead gives the direction of the vector. The length of the arrow gives the magnitude of the vector. In grade 11, we are introducing you to 3 different ways in which you can represent the direction of a vector. The first one is a Cartesian Coordinate System, which uses the x and y plane. The second one is the compass direction, which uses the north, east, south, west, together with its cardinal points. Then the last one, it is the bearing direction, where we're only focusing on the angles measured from the north line as a reference point. Cartesian Coordinate System, well, you've been using it since primary school, where you are plotting points to draw a graph. So a coordinate is a data point that has an x and a y. When we read the x value, we're focusing on the horizontal axis, and when we read the y value, we focus on the vertical axis. So let's see if we can do this. So vector A, its coordinates will be what? I look at the horizontal first because that is the first point. The x is the first point, followed by the y. So the x is on the horizontal. It will be how much? It will be 3. Then I go up and I get here and I get that my y is a 3. So when I write the point, it will be 3 and 3. That will be for point A. Let's look at point B. I go horizontally, it's 3. Then I go vertically, I get -5. So it means for point B, I have 3 and -5. Let's look at C. C is lying exactly on the x-axis horizontally, so the value is -4. We don't have any value for y, so C is going to be -4 and 0. Let's look at D. It's lying exactly on the y-axis, so that will be what? The value here is, so the value will be 5 and 0. I think that's pretty easy. So if I ask you the point here, the origin, what would you say the coordinate for the origin will be? So the coordinate for the origin will be 0, 0. Don't forget that. Compass direction method. When representing the direction of a vector using compass direction, we focus on the north, the east, the south, and the west of a compass. So if I draw a vector here, you will tell me that this is northeast. And this one you will say it is southeast. And this one you would say it is southwest. And this one you would say it is northwest. Right? So the method that you used to actually name those vectors or those arrows, it is the square bracket convention, where you only focus on the letters. Okay. Another thing, you can only say this is true provided the angle that is given is 45 degrees. So the angle from the north to the vector must be 45 degrees for me to say northeast. The angle from the east to the vector must also be 45 degrees for me to use northeast. Same applies throughout all of these angles, they must be 45 degrees in order for me to say northwest, northeast, southeast, southwest. Because this tells me that I am half away from the north and the east. And half away meaning the angles must be equal, because this is a right angle. The angle here is 90 degrees. So if I use the square bracket convention method to write the direction of that vector, I would say what? I would say N, where am I starting from? From the north. The angle, 45 degrees. Where to? To the east. That's when I'm starting from the north. I'm going 45 degrees towards the east. If I was starting from the east, going towards the north, then I would say east, 45 degrees north. That is the square bracket convention method. Simplified, we'll just say northeast. So when we use the of convention, we're focusing on the angle, the vector that we are rotating to, of the vector that we're starting from. So what is happening here? I am starting from the north. I am going where? To the east. At what degree? At 45 degrees. So when I write it, it will be what? The angle, 45 degrees. Where am I going? I am going to the east. This east is the east of what? It is the east of north. Starting from the north, I'm rotating 45 degrees to the east. This is the east of what? This is the east of north. This is what I mean here. East of north. Where I'm starting, I'm going to the east of it. I hope it makes sense. Let's do examples. Let's look at vector A. The angle is given between the east and the vector, and the angle is 30 degrees. So I move from east going towards the south 30 degrees. So when I use the square bracket method, the answer will be what? My A, the vector A, the direction will be east 30 degree south. Okay? Now for vector A, if I use the of method, what is it saying? I'm starting from E, the east. I'm going to the south. The south of what? The south of east. So angle 30 degrees where? To the south of what? Of east. I hope it makes sense what we are saying. Let's look at B. The angle is between the south and the vector. And the angle is 70. So if I use the square bracket, it tells me the letter where I start, the angle that I'm rotating, and the letter where I am rotating to. So for vector B, I'm going to have what? I start at the south, I rotate 70 degrees, I rotate 70 degrees to the what? To the west. If I use the convention, the of convention method, it will say what? I'm starting at the south, going to the west. The west of what? The west of south. At what angle? 70 degrees. So that will be 70 degrees of what? West of south. Forgive my handwriting. I'm using my fingers to write. I do not own a stylus pen. Let's look at the last one. C. Let's look at the last one. C. So what is C saying? The angle is between the west and the north. So I'm moving from the west at 60 degrees to the north. So that will be what? West, I'm starting. I'm rotating 60 degrees. I'm rotating to the north. So if I use the off convention, I don't think I'll be able to write it down here. Let's see. If I do the off convention, it will be what? I'm moving from the west going to the north. The north of what? The north of west. At an angle of what? Of 60 degrees. So that will be 60 degrees, what? North of what? North of west. The only way you can know if you understand something is when you redo it for yourself. So do these activities, leave your comment on the comment section, and I'll check if you did it correctly. 1 is for the square bracket convention. 2 is for the off convention. Write it that way. The last direction that we're going to focus on is the bearing direction. So with the bearing direction, we're taking the north of the compass as our reference line, and we are giving it a bearing of 0 degrees. When we measure the bearing angle, we are always going to go clockwise from 0 to where the vector is. It doesn't matter which side the vector is. It will always be measured clockwise from 0 to the vector. And always keep in mind, bearing is always between the north line and the vector. So that's why we do the arc to see how much is that angle between the north line and where the vector is. The north line and where the vector is. Always, always, always draw an arc to see the right angles. So now, if I tell you this angle here is 35 degrees, and I ask you, what is the bearing of A? What will your answer be? We measure the angle from 0 to the vector. The angle that's given 35 is between the north line and the vector. So it means that A is at a bearing of 35 degrees. So now, if we look at this vector, we do not know the angle that's given. So if the angle is given here, then it will be included within the arc. But if the angle is given here, it is then excluded from the arc. So when I have the angle included, I add it to what? To the last big angle that I passed. And if the angle is excluded, I minus it to the big angle that is to come. It will make sense when we do the examples. Let's look at 3.5. Remember, I start from 0. I forgot something very important here. So this is 0. This is 90 always. This is 180 always. This is 270 always. And this one, we share it between 0 and 360. I completely forgot to mention that. You can arc coming all the way this side. So if I check the given angle, is it included within the arc? It's nowhere inside the arc. It's not included. That means this is not included. I have to do what? I have to minus it. Where am I going to minus it from? I must minus it from the bigger angle. So remember, 0, 90, 180, 270. So because I've already passed 270, 270 cannot be my bigger angle. So my bigger angle to come is 360. So it means I am going to minus the 52 from 360. That means 360 minus 52, which is 308 degrees. So it means this vector, if I give it the name A, it will be at a bearing of 308. Let's do one where the angle is included. 3.7. Again, 0. This is 90. This is 180. And this is 270. My arc starts from 0 all the way to where the vector is. So if I look at it, the angle that's given is included within the arc. So because it's included, I have to do what? I have to add it. To which one am I adding? To the last one that I passed. I passed 270. So that means bearing here will be 270 plus 71, giving us 341 degrees. So if I name this vector B, it will be B is at a bearing of what? Of 341 degrees. Can you try others for yourselves? Remember, first draw the arc to form 0 to the vector. Check if it's included or is it excluded. Try it out and let me know. Let's look at 3.6 before I go. This one is quite easy. The vector is lying exactly at 90 degrees. So even if I make the arc, it really doesn't matter. The bearing here will be 90 degrees. It's straightforward. Try and do the others. Try and do the others and leave your comment on the comment section. I'll check them out for you. Thanks for watching. Please share the video, comment, like, and subscribe.